Hi all, it's midnight in Moscow time zone. My name is Vladimir, and you are watching the Nightly Code channel. As far as you remember, we are working on the Focusrite Scarlett Gen 3 device series driver for Linux. And at the last stream, we have completed the what have we done? We have completed the routing, the switching between the stereo and mono mode for the outputs. And the homework that I promised to do was to implement the proper switching of the pair of outputs when the output is in the stereo mode, when the pair of outputs is in the stereo mode. So as I promised, I did this job, and let's look at the result. So I'll open the Scarlett Gen 3. Oh, Leon, good evening. Good evening. Okay, and as I have promised, I did the job, and let's look what we got. I have updated the Scarlett Mux source enum port function, added some additional debug information to it, and more important thing, I have implemented the code that allows us to switch the pair of outputs for the device. So the code looks a bit confusing, but this is a pretty correct code. We get the value of the new value that we assign to the output routing. Then we can compute the delta between the new value and the old value. This is important since we know where we are going. We are going towards the raising the number of input, or we are going towards the lowering of the number of input. And if the delta is 0, there's nothing changed, and we can just leave the function. Otherwise, we need to check that the output is working in the stereo mode, and if not, we just set the root and update the mux or the router of the device and leave the function. By the other side, if the output is configured in the stereo mode, there is more complicated behavior of the device or of the driver. We need to compare the value with the special number, which means that the output is not connected to any one input, and there is only one value, but we get this value from the constants of the device. And if this value is as we consider that these values are the first and the least, then we can just compare the value that was provided from the client software to us with this number and check whether we are routing the off state to the output or some input channel to it. So if we are routing some input channel to it, we just need to check if the provided port number is odd or even. And if it is the even number of the output, we need to lower this value by 1. So this means that we configure the even output. But this is the same as we configured the odd number of output, starting counting from 0, of course, and setting just the value lower by 1 to it than for the even number. So we just do this to implement additional branches that work with the odd number of input rather than the even number of the output, rather than the even number of the output. So after that, we just check that the value we get the number of the input in case of it is assumed to be in the stereo input too. So we need for the even output number, we need the match the input to be the even too. So that's why we just substitute the special reserved value as off from the provided value and decline the last bit. That means that we make the value multiple of 2. And after that, we do the same thing with the old value. And if the value is equal to the old value, that seems that for the order input or the output, we have set some even for even output, we have set some ODD input. And that's why we need just to increment this number or decrement this number depending on the direction we are going. So in this way, the delta value we've previously calculated helps us. So if the value hasn't changed, then we need just to add 2 or subtract 2 from the number that we need to set. And after that, we just clamp the value to not to go out of the available range. And after that, we assign the number of output for the ODD output corresponding to the even output, greater by 1 to the left channel when the value is not set to off. And after that, we just for each channel in the loop apply new routing and apply new software configuration. And moreover, we notify the driver, the client software, that the corresponding port number, port state has changed, and the driver software needs to synchronize the state by reading the state of the control from the driver. This is that code. And if there are some errors, then we go just to unlock and finish the processing. So that's the primary logic, and we can check it now. So I don't have the connection. We just need to connect the device to the Linux machine. Here it is. We can see that the driver has found the device, and we have read the configuration from the device. And now we can check in the also mixture that all is fine. So let's run it and select the device and look at the buttons. So I'll scroll it to the end. And here we have a stereo switch for SPDIF. So if we just set the SPDIF output 1, we can scroll it to the next value, and we get the 8.1. Then we scroll it again, and we get the 8.3, and so on and so on. And ending up with mixture settings. And lowering the value, we get the analog 7, then analog 5, analog 3, analog 1, and off. And please notice how the SPDIF output behaves too. So we set the analog 1 here, and the analog 2 is automatically assigned at the SPDIF output too. Analog 3 and analog 4 is automatically assigned to SPDIF output too. And we can do the same thing for the second output and look at the first output. So when we set the value 6, the SPDIF output 1 is set to value 5. And so on and so on. Moreover, I additionally have added to the code the correct remapping of the outputs. So now we can just watch how the stereo switch for analog outputs 5 and 6 can work. So we just set the analog 5 to 5 and analog output 6 is automatically set to 6. What will be if we just switch from stereo to mono and set the analog 6 to as an output for as an input for analog output 5? That's pretty simple. The analog 6 is one of the pair of analog 5 and analog 6 are inputs, and that's why the analog output 5 will be routed to analog input 5 when we will switch to stereo. Let's look. And that's pretty correct behavior. So, and moreover, there was a problem with the PCM outputs. I have reviewed the routing code for PCM outputs, since we have the PCM 11 and PCM 12 being the loopback special outputs, the special loopback outputs, and we just were required to also properly handle the routing for these outputs. I think I need to switch to F5 all. Yes. And we see now that there is PCM 11 and 12 capture stereo. And we can just see that there is independent assignment of PCM 11, 12, as we see here. And when we switch to stereo, then PCM 12 is assigned to AD2 back. Since the ODD numbered channel starting numbering with 1 is more prioritized than the even numbered output channel. So that's how we handle the state of the device at this moment and how the driver behaves. That's all good, but the main problem is that we haven't even touched the mixture routing of the device. And mixture routing is done in a special way in Focusrite, and we need to learn how it is done today. And I believe we will write the corresponding code to handle this behavior correctly. So let's do what we are targeted to do. So let's disconnect the device from Linux virtual machine, and let's connect the device to the Focusrite to the Windows machine. So here was the device found. I'll close the Focusrite control to be sure that it will apply the settings to the device, since we have had problems with Focusrite control previously. And now we will do the, as usual, launch the CMD as an administrator. Yes. Switch to USB pickup and grab the traffic. Also, we need to disconnect the device at this moment. Oh no, we don't need. We should first initialize the routing of the device. So we will at first connect the device, prepare for capture the traffic. So let's change the directory. USB pickup. And here it is. All right. Now we will do the following thing. Okay, we need to check that analog 5 and 6 are switched to stereo, and the SPDIF is also switched to stereo, but is in the mute mode. So let's unmute this all, switch from stereo to mono. And now we are ready to change the routing. I'll just reinitialize the routing with the analog 1 input. And at first time we will look how the routing in the mono out for the mono outputs behave. So I'll this do in the short time. We're almost done. And here we are all done. We have all done correctly. At this moment, I will just disconnect the device and ensure that the settings are pretty correct. So I'll disconnect the device, close the Focusrite control software. Then I'll launch it again and and connect the device. Oh no, I need to launch the capture of the USB packets. So I'll set a 1 and name the file to Scarlett 18i8 mix mono routing pickup. And after that, we are ready to connect the device and check what's happening. Okay, we'll see that the routing is pretty correct. And now we just need to assign the custom mix to the outputs. So let's do this. Custom mix. Custom mix. And so on. Until we are fully out of available mixture lines. Oh, we're done with the number of outputs, of number of mixes. Let's look. 1, 2, 3, 4, 5. We have only 5 custom mix lines available in the device. We don't have any more. So let's write down this, what we have found. So we need to write this here. The number of mixture lines for this was the 18i20 device. 18i20. And we're writing down the information about the Scarlett 18i8. So let's add this here. The number of mixture lines for the 18i8. So we don't know anything about the inputs at this moment, but we know something about the outputs. This is up to 10 outputs for the device. The Focusrite software doesn't allow us to perform the full routing of 10 outputs for the mono. Uh, we need probably to stop the capturing since it will be too large file. Okay. Um, this is because Focusrite allocates the mixture lines with a pair of outputs. So we will look at this in the protocol dumps. I think we need to check what has happened when we have written this when we have captured these settings. So this is the first protocol dump, and we'll probably launch the second protocol dump by switching custom mix from the first analog input to the next free analog from the first analog output to the next free analog to the next free output, and so on. So I'll just write down the one. We need to disconnect the device as usual. Then we need to do the following thing. We need to write the name of the file, Scarlett 18i8 mix mono switch pickup. And now we are ready to capture the changes made by the driver by connecting the device, reading its configuration, waiting for a short time, for about 10 seconds. Oh, and we don't have the configuration applied. That's bad. I think I probably need to relaunch the Focusrite control. And probably we will solve this problem. And let's launch it again. No. We need to rewrite the protocol dumps. That's bad. Okay. We'll disconnect the device. Close the Focusrite control software. Cancel the capturing. Delete the files. Scarlett and mix mono routing and mix mono switch. And we need to redo this all. So let's launch the USB pickup. One Scarlett 18i8 mix mono routing pickup. Then launch the Focusrite control service center. Connect the device. Yes, bad things happen. So probably we are ready to redo our job. So custom mix. This is the third custom mix. This is the fourth custom mix. And this is the fifth custom mix. I believe we have no more. Yes. I think we can combine. And now we will do the following thing. We will disconnect the custom mix from here and connect it to the beginning, to the next free analog output, to the next free output. So let's do this. Analog 1. And assign it here. So custom mix. Disable it here. And enable it there. And so on. Okay, only 4 outputs are left. Only two outputs are left. Yes, these mix are hardware mixers. These are mixture. The device has internally an matrix mixture. We have 10 outputs of this matrix mixture that can be assigned to any output of the device. So another one, and assigning the last ones. Okay, we did it to back devices. But I believe that's not significant. We will find out in the protocol dumps what happened. So as I have said previously, we have 10 matrix mixture output available in the 18i8 device. So I need to stop the capturing at this moment, disconnect the device, and copy the file to my host machine. So we need to go to the C, program files, USB pickup. Where's it? Here it is. And here's the mono routing information. So let's copy this to this virtual network share here. And now we are ready to decode these protocol dumps. Can every output have a different mix, or is it just one mix with multiple outputs? What I can say, actually, the device internally doesn't prohibit us to assign the same mixture output to the multiple outputs. But this is not allowed by the original Focusrite software. So if we switch from the Linux version of driver to the Focusrite control, it will break our settings if we route more than one output of the device to the same mixture output. By the other side, it is not a problem to read the configuration of the Focusrite control and apply it to us. So we will do it as most as possible compatible with the Focusrite device, but we cannot guarantee that this will be 100% compatible, since the Focusrite control driver doesn't allow us to assign multiple outputs to the same mixer line. I believe that's it. Anyway, we need to decode our protocol dumps. We already have this file here. So this is mixed mono routing. And we can launch, as usual, run sh and provide the file name ff Scarlett 18i8 mix mono routing pickup. The file has been processed, and now we can read the decoded information. Okay, no problem. I can say the following. The internal router of the device is pretty flexible. It can connect any provided input to any provided output. And it has around 60 connection points. So the device internally is more flexible than the Focusrite control allows us to do. And that's pretty cool. By the other side, the original Focusrite control can break our settings when launching the device under Windows or Mac after we have configured it in Linux. And that's why we need to make the at least less negative effect of this. So let's look at the pickup decoded file. We will open it with Kate and look. So here it is, Focusrite Scarlett backports, reverse engineering, and clean. I'll turn off the line wrapping as usual. Yes, we'll load. And now we're ready to look what happened when we were working with the device, with the mixture routing. So that's nothing happening here, just pulling the meters of the device. As far as I understand, this is the following code. And after that, we have the first setmix message. Setmix message. The setmix message initiates the state of the mixture lines, of the mixture line or the multiple mixture lines. But we see that setmix is applied to the channel 0. This is the 0th output of the mixture. And as we see, the device has allocated the 0th mixture line for the first output. And what we can see here, we have the set data changes at the offset 16AE, but that's the control sum. And we have also the changes at 19FA, which is the, according to my previously investigated observations, this is the custom mixture routing bit mask. So we'll write down what's happening here. We'll create new file, put it at the right, and we'll write down that 19FA. We have the bits changed from the FF to FE, and we will write down that this is the channel 0. This is the first change from the driver, and I see nothing else has changed except the mix state has been updated. That means that the mixture output 0, if we count from 0, it was assigned to the corresponding output, and probably we'll find it here. That was the analog output, and we need to find the analog output. And here we see that the mix 1 is assigned to analog output 1 in the routing. So that's pretty correct. Let's look at the next change. And here it is. As we see, the Focusrite driver has taken the mixture with channel 2 for the next assignment. And as we see, with that, the mask, the mixture line allocation mask has changed from FE to FC. What does it mean? That means that the mixture software implemented by the Focusrite channel 2 has set the bit 2 counting bits from 0 with zero. That means that the mixture the mixture is enabled. The mixture line 2 is enabled. And also we see that the F9 bit has changed from 1 to 3. That means that the F9 is the routing of the analog output 1, or of analog output 2, as we remember from our table. F8 is the beginning of the output routing. So, did this change the previously? I need to check again. There was set mix, set data. I believe the problem was that there was already the number. I understand what happened. The number of the output was matching the the number of the mixture line, and that's why the byte F8 wasn't changed here. So we need to write down that F8 was changed from 01 to 01. But for the second action, the F9 was changed from, I don't remember from what, I believe from 1 to 3. Let's look again. Yes, that's too far. Here it is. Set data, and we assign the value from 1 to 3. Sorry, not that right. So we see that output routing contains information about the output mixture line used when the bit mask is set to 0 for the corresponding mixture number, mixture line number. Let's look at the next change. Here we see that the I probably need to scroll again. That the FA value was set from 1 to 5, and that seems to be correct. And then after that, the value at the offset 1C B4, 18 BC, and we need to 18 FA, and then 1960 and 19 FA. Yes, okay. This probably is related to the loudness. I need to check again. Oh, this is the mute settings for the mixer channel. So we won't look at these changes at this moment. We need the only FA changes. And as we see, the changes that we made is from FC to F8. So one more output was changed. But that's strange. The change from FC to F8. That's interesting. I also need to check if I believe there was every output set to mono. Anyway, let's look more. If we did the wrong thing, then we were probably mistaken. I need to check again the device connection and hardware settings. No, that was mono mode. So yes, but we don't see the assignment of custom mix here. Oh, that's bad. Anyway, I believe we will see that in protocol changes. So FA 19 FA was changed from FC to F8. That means that the third bit was reset, but the channel 4 was set. Now that's pretty strange. Why F8? Hmm. Probably mixture software has additional bugs inside of it. I don't know. Anyway, let's look further. The next change. And here's our the next assignment. The channel 6 was taken, and the changes made for FB were set. This is pretty card settings. Oh, FFFE, FFFC. This means that the bit 1 was reset. Yes, then the F8, and then will be the F0. Yes, the F0. No, uh, that seems that channels of the mixture are allocated in a bit different way. We'll look at how they will be allocated in stereo. So this is the channel 6, and the last channel will be the channel 8, and we'll probably find it here. The channel 8 was allocated, and the routing was set to 9, and the channel 8 was allocated, and the F was changed to E. Yes. So as we see here, uh, the mixtures the mixture is allocated with single channels, and each channel is working as an single bit in the bit mask. But that's pretty strange. Let's look what's happening after that. We have removed the mixture, the channel, the output mix assignment for the channel 1, and assigned the output to the channel, not to the channel, to the output 6. Let's look. So we see that set data was changed, and as usually we didn't change anything since the output, the number of the mixture line was the same to the number of analog output, and we have the value 19FA set from E0 to E1. That means that the bit 1 was set to 1, and the mixture line is not initialized by the driver. Then we have assigned this to the output 6. This is 1, 2, 3, 4, 5, and 6th output. And what's happening there? And there we see that the routing still wasn't changed, that this is the mixture channel 0 again. And the offset probably will be F. That was the FB, and that will be the F9, FA, FB, and FC are probably, and then will be the FD. And the change, change was set from from E1 to E0, I believe. From E1 to C1. What? From E1 to C1. What's this? I still don't understand how the allocation is working. Oh, I know this. All right. This is not related to the mixture line. This is related to the number of the output. And that's right. This is the custom mixture routing bit mask, and the bit is responsible for the number of the output, not for the number of the mixture line. And the actual mixture line number is stored in the routing table. So that's it. And that's why we have not the E0, but we have C1. Yeah, as you remember, the C1 in binary is the 1100 and 1001. And that means that we have 5 assignments to the outputs, and these outputs are from 0 to 5, to 6, are numbered from 0 to 6, starting with 0. So that's good. And as I understand, the next assignment will be as usual, and we won't see anything special. From we have reset the routing for F9. That's good. We have set to C3, I believe. Yes, C3, and so on, and back to the next change. Yes, we have taken the channel 2 as it is the first free channel available on the Focusrite driver device, and we just assigned the 01 to 03. Yes, routing. That's pretty right. Okay, now it's clear. How does this work? We need to explore how it will work in the stereo mode. And C3 to 83, that's right, and so on and so on. So that's clear. Let's do the next protocol dump. We need to restart the Focusrite software, disconnect the device. We need to initialize the device first. Probably I need to learn how the switching from mono to stereo will work. So what? That's not correct routing at all. Or probably. Oh no, that's not. Probably. I think I need to do the following. This thing. The custom mix. I think I need to switch to playback, since playback has another numbering node from 0, and that will be much better visible for us. What changes? So I'll switch to playback. Okay, and I think we need to enable the custom mix for the first outputs. Now, custom mix, custom mix, custom mix, custom mix, and custom mix. That's okay. Now we can close the software, launch it again, check that the settings have been applied. And after that, we can disconnect the device and grab the changes that we will make. Okay, that's pretty good with custom mix. Seems that it is set correctly, yes. And now we just disconnect the device and do use the usual things for the dumping the protocol of the USB exchange. So let's launch the USB pickup CMD. Switch to 1. We have the device disconnected, right? And now let's write the Scarlett Scarlett 18i8 mix mono to stereo pickup, and let's do the usual things. Let's connect the device and switch from mono to stereo. Up, up, and up. We don't have any custom mix assignment more. Probably we will do the next thing. We will just assign more mixes, but I believe that Focusrite control won't allow to do this for us. Oh, it allows to do this. Okay. Custom mix. Did it set? And the custom mix more. Hey, Focusrite. Where are my changes? It doesn't allow me to set the custom mix more, as we see. So, let's do one more thing. We will switch all outputs to stereo and route the custom mix for this case. So that's not right. We'll take this. We'll reset all settings to playback 1 and 2. Switch to stereo all other outputs. It has already set to playback 1, 2. And now we are ready to close the software, disconnect the device. And after that, we are ready to capture the changes. We'll set the 1 and write the Scarlett 18i8 a stereo mix pickup, stereo mix routing. And we are ready to launch the Focusrite control and connect the device. Okay, now we're ready to set up custom mix. Okay, custom mix. Okay. Custom mix. Okay. Custom mix. Okay. And custom mix. And we don't have any custom mix more. So we have only 10 custom mixes available. So let's turn off the custom mix here and turn on the custom mix here. All right, we have did all what we need. And now we can stop the capture and copy the files to the host machine. So we need to open a new window, program files, USB cap, mix mono to stereo and stereo mix routing. Okay. This and this we'll copy here. And let's analyze what's happening in the first and the second protocol dump. Let's do the run sage. Scarlett, FF Scarlett, FF Scarlett, 1898, mix mono to stereo pickup. And let's look what's happened. Reload the file and check. So here we have so what's this? Oh, okay. Hi Asia. Okay, what has happened here? The one before offset was the one before. Mono to stereo switch output for channels. Ah, yes, that's right. The one before was changed from 3 to F. From 3 to F. Probably I have did something before. Too quick. Yeah, yes. There's an additional change from my side. And here the change from 0 to 3, I have switched the analog output 1 from mono to stereo. And there's one C2 also changed and one BE. Let's look was the one BE. Logic mutes for outputs. Okay, there. Oh, okay. That's the mute was unset for the output. That's right. And BC the volume settings and one C2. Yes, that's still the volume settings. Okay. One A6C and one A6E are the settings of the control sum. And I see that nothing has changed related to the mixture settings. So we see that when setting the routing for outputs in stereo mode, the Focusrite control doesn't affect the number of the even channel if we start numbering from 1. So I think that's not pretty correct, and we can do the right routing information change. anyway, now we know what's happening. Uh, the the only change was made to uh, the software configuration space is that um, in our case that the stereo to mono switch was set. When we will write the driver, we need to update the routing for the second mixture, probably. Okay. So let's look the next changes. I believe there will be the same. So there was a change, and before was set from 3 to F. That means that the again before is the mono to stereo switch. Yes, and nothing else happened. Okay, so this is this protocol dump is not interesting anymore for us, and not interesting for us anymore, and we need to watch the next. What was there? The stereo mix routing pickup, and let's look at the changes that we have made. Sorry. Let's go to the beginning. There is an initialization sequence, the additional initialization, and after that, we have our device initialized, and the channel 0 was initialized. We set F8 from 13 to 1, the only 1 byte. And after that, we change the mask at 19FA from F5 to F4 and change the checksum. F5 from F5 to F4. Again, why it's so? F5 means that, oh, sorry. Probably I've missed something again, and some settings were applied previously. Yes. Probably. No, not this. Probably here. No. Maybe here. No, this is channel 0. And the F5 was changed to F4. As you remember, F5 is 111111010. Oh, sorry, 0101 in binary. And it was changed from F5 to F4, and that's very strange behavior. Okay, let's look what's happening what's happening next. Then it's changed from F4 to F0. That's pretty correct. Then what's next? Then it was changed from F0 to E0. So to this. So actually what we see, the Focusrite control modifies only the even numbered bits when performing the mix allocation, the channel assignment. So actually now we can conclude the following. When the channel is in the stereo mode, then the only even numbered bits are set, and the mixture is allocated with the pair of probably set mix channel 4, set mix. Okay, channel 4. Okay, and where's the channel 5? Channel 6. And set mux. Mix 1 assigned to an LEC 1, mix 2 assigned to an LEC 2, mix 3 and assigned to an LEC 7, mix 4 to an LEC 8, mix 5 to an LEC 3, mix 6 to an LEC 4. Mix 7 is assigned to an LEC 5, and mix 8 is assigned to an LEC 6. Became assigned to an LEC 6. And was with the max, the E0 was changed to A0. So to this. Okay. Now we're pretty ready to understand how to read the proper routing information from the Scarlett device. Let's look into the code where we read the routing information. Probably this is in the init mux function. Add mux enums. Probably this. Yes, here's the software configuration. And what we do here, we read we compute the port number of the device and read the mux settings. So we need to write the comment here. So the comment will be the following. Convert the driver port number to the Focusrite control port number. And this is the output number, not port number. to driver output number to the Focusrite controller output number. Oh, this is the input number. Get driver to software port mapping. Yes, this is the right. And here we convert the input number to the Focusrite input number. And here we need to do some tricks, I believe. First of all, we need to read the bit mask from this U32 mix enable mask, and here if the software config is present, then we need to read this mask from the software config. And we need to look at the description of the software config again. And here the mixture bind. I think I need to rename this field to custom mix mask. I think this is good naming for the value. And I will rename the variable to match this value, custom mix mask. And this custom mix mask, private software config, custom mix mask. And we need to convert then we need to match the Indianness of the value. Then we will write to LE32 to CPU. Oh, sorry. This is the private. Okay, and we can write ternary operator instead of if. So that will look like this. And commanded read the custom mix mask if it is present. So here after all of this stuff, here we need to properly decode the mux number. So the software port number, private software config output mux. But we know that we cannot convert the number being assigned here, being stored here, into the direct value when the then when the bit mask is set to 1 to 0. So this is true if the mask is set to 1. If custom mix mask and 1 shifted to index, I believe 3 is shifted to index, right? No, 1 shifted to index. And we also need to read the stereo assignment, the stereo mode. Stereo is a switch. And we need to go back to the non-ternary operator. So stereo switch 0, custom mix mask 0, and if private software config is set, then we read the custom mix mask as LE to CPU of this field and LE to CPU of that field. This is stereo switch. Yes. And not the custom mix mask, but stereo switch instead. So we know that the stereo switch, we need to write the logic here. When the custom mix mask is set to 1, then the following is set to 0 when the corresponding bit for the custom mix mask is set to 0, then the mix assignment should be done. Mixture assignment. Otherwise, the input is assigned to output. So we need to check that the output is configured in the stereo mode and check that the bit mask is set properly. So what we need to do this? The software port number is still that, but here we need to add the condition and how this condition should look like. We need to think. If the okay, we need to check first that the mixture is set, and for stereo that should be the check in the first manner, and for mono that should be the check in the second manner. So we need to check the stereo switch first. I need to check the mapping again for the device of the outputs. Let's look. Where's the mapping? Okay, here it is. The 1888. Okay, and the PCM has the hardware offset 10 and okay. All right. What we do have, we have the non-analog SPDIF ADAT PCM assignment of the outputs and analog SPDIF PCM assignment of the inputs. And now we're talking about the inputs, but in our case, the output of the mixture is considered to be the input of the device. So we need to check that the port is in stereo mode. We just use the usual case that we need to shift the value to the left by the number of bits, truncated with the least significant bit discarded. So let's do this. So this is int error and stereo index, I believe. Where's the index variable? Okay, here it is. I need to move it to the top of the function. Int index and stereo index. Okay, and now we're ready to assign the stereo index value. Stereo index is the index and the least significant bit discarded. Yes, and now we're ready to check for the stereo assignment and for the mux assignment. So I think we need to use we need to check for the stereo first. So if stereo switch and the 3 shifted. Oh, we don't need that. We need to do this. Index 1 shift 1 by 1. 3. No, that was correct. Shift that stereo index. That means that the outputs are configured in the stereo mode. Then we do the stuff. Else this code. And we need to write properly here that outputs are configured in mono mode. And here outputs are configured in stereo mode. So after that, we need to check that the output is initialized correctly. So we need to convert the number of the software port. We need to convert the software port number to the actual mux output number. I think we need to do this at this time. And here we need to I need to sometime to think. Okay. Here we consider that we know that the stereo that the port number is set to that the port is initialized as stereo, and we need to read the value from the even number ports. We count from 0 and add 1 to this value here. So, and also this should be done for the if we use the mixture settings. Or does it even work in stereo? I think this is independent on what we are doing. So even if we are in stereo, we need to read this value. So we need to truncate index. So we need to read the value at the stereo index. So here it is. And that's pretty correct. Yes. And that's nothing that we require more. Or we need to check that this is ODD number and add this and plus index and 1. So that's good. And we don't need any more anything. And after that, we need to check that the port is configured as the MUX. And we can do this by just applying this mask to 3 to the inverted value of the stereo mask of the mix mask, custom mix mask, and if it is non-zero, then we can actually say that the output is used as the routing to the mixer. So if inverted value of the custom mix mask and this value is not 0, then we can say that the mixture is used in that the mixture is routed to the output. Otherwise, the usual output, the physical input was routed to the output. Yes, else. Here we write the comment. The mixture output is routed to the physical output. And here, the physical input is routed to the physical output. And here we need just to add the number. We need to compute the right way number of the port for the mix, and that's not pretty hard. We can just compute this by following instruction. We need to pass the Scarlett 2 port out. I bring port out. I need to look at the configuration. So MUX assignments, port type PCM and expective PCM mix 8. Y8. Oh, that's the GAN. That's another device. Mix. This is the 188, and we have the mix 20 inputs. Where's the assignment? Oh, here. Mix 10 inputs and 20 outputs. That's right. Oh, sorry. 20. Yes, 20 outputs and 10. I don't like this in terms that for mix, the inputs and outputs are working in reversed manner. So we have 10 outputs and 20 inputs for the matrix mixture. And we need to compute the Scarlett 2 port out Scarlett 2 port in mm, driver port type Scarlett 2 port type mix and driver port number uh, the actual software port number -1. And this is pretty enough to get the right routing. Except that fact that if the software port number is 0, that doesn't matter at all. So if a software port number is greater than 0, then we do this thing. Oh no, we need to do this here. Oh, the replacement is greater than 0, then greater than 0, then we call this. Otherwise, we need to assign it to oh, we can do the oh, we can do just this or assign just 0. So we can do this is less than 1 or I think I need to look at the mux in ctl put mux src in still put, and there's the check for the number of non-count, and we just copy this. Just copy to here to this place. So int non-count private private info port count. I'll copy this here. Do we have port count number here? No, we don't have it anymore. We can just refuse this. Private info port count. And we can refuse this here too. I don't like this construct. And what we should, if the value is less than non-count, oh, we can just compare it to, yes, we can compare it to non-count. That's enough. Is less than non-count, then we just assign 0, else we call for the assignment. And here, so I think we can skip this since the SCAR2 driver port number to mux num does the right thing when converting. Or not. No, it doesn't. So we just need to, I think the more right way will be specifying the port type. So we'll do this. Uh, we'll do this. So compare, and if all is okay, then we call this. Instead of this, we'll call another branch and pass the SCAR2 port in, SCAR2 port type none, and the value 0. So that's pretty enough. And here we will do the same thing. Software to driver port mapping. Here's pretty good. The software to driver port mapping will return the invalid value, and all will happen in the right way. So if we don't find the value, we will return just 0 and return the port type none. That's good. So we don't need extra checks here. We just need to check the value here. And after that, probably we will see that our mix assignments are right. So I think we're ready to compile the kernel driver and check. So let's do this. I think there will be probably errors. Yes. Unused variable. Okay. 4213. Let's go to that line. And we don't need to the infrastructure here. Okay, that's good. And probably that's all. Mike J8. Okay, it's compiling now, and we probably we have the routing settings applied, and we need to look at the log of the driver that it has properly found the right input. So we need to look at the analog output and ensure that the analog output is assigned to mix 1, analog output is assigned to mix 2, and so on. I have the stereo settings now. Okay, now we see that the driver has compiled. We need to do the usual thing, just RM mode, sound, USB, audio, and copy the driver. KO to lib modules 15, what's 515, kernel, sound, USB, SND, USB audio KO, and remote probe this. Okay, now we're ready to look at that lack of the driver, and we need to just to connect the device, disconnect it from Windows machine and connect to the Linux machine. Okay, let's do this. Focusrite Scarlett 89 USB, right. All right, what do we see here? We have the routing initialization, and that seems that we have improperly configured the value. Mux 0 set to 0, Mux 1 set to 0, and so on. So that's not good, and we need to check again what's happening in the driver. So we need to dump the value and log the changes. So we need to write USB audio info. Oh, here's the software routing. Okay, let's do this. So we need to write the stereo switch and the custom mix max state here. And pass them. And we need to write the additional information here. So we need to write the values of our variables. This is the software port number, the stereo index. Oh, I think I probably know where I was wrong. Or not. Oh, the index. Just write the index. Software port number, the stereo index, software port number, and probably the mask. I think this should be done here before we perform the check. And mask. So we will write here the the index, the software port number, the stereo index, and the mask if we have computed this. Okay. Here we'll write the updated software port number, just updated software port number, and here we software port number -1. Okay, and here we just mux input number. We compute the mux input number, and we'll write the following thing: USB audio info. That's pretty strange. That seems that we have improperly read the value. Anyway, we need to check all. And here we will still write the log information. I'll do this. So this is the mix routing. Software port number, driver port type, driver port number, why the software port number, oh, that's the I. Why the software port number? Oh, all right. Mux input number. Oh, this is the conversion. What's the S? Port type and channel. Port type. Then type of the output port. And channel the number of the out. Okay, this is pretty right. This is the destination. This is the number of the port. The software port. No, okay. Let's look again what's happening. Then we need just to recompile the kernel driver, disconnect the device, and relaunch all the stuff. Probably we will have missed something, and we will check at this moment what's happening. We'll find out. I also can check that mask stored there at this moment. I just need to recall the offset. The 19FA offset. The 19FA is a bit is here 19FA and there's A10A. So there are non-zero bits. And moreover, when we initialize the software configuration area, we need to fill this value of the f's. So let's do this. Read software configs, and here we initialize the software configuration area. And we need to write the proper value here. Software custom mix mask to f's, to all f's. So I believe in this manner. I think the compiler will allow us to do this without any super extra notifications. Yes, that's right. Okay, now we are ready to replace the driver and check the logs. So let's do this. Demask, replace the driver. Yes, the driver has been replaced, and now we're ready to connect the device. Okay, let's look. Oh, that's pretty strange. Let's see what's happening. Here we have an uninitialized value. So the value 19. Software port number 19. Why 19? Let's look into the routing. What's 30 means? I think I need to check the driver settings by Focusrite again. So I need to disconnect the device. These values are uninitialized probably. Yes, driver type, driver port number do not have any meaning here, so we need to remove them. Okay, and after that we need to connect the device to Focusrite control and check what's there. Oh, that's the playback 1 to 2. Then custom mix, custom mix, custom mix. custom mix. Oh, okay, I understand. Now we need to disconnect and check that we have properly applied the configuration. So let's go back and connect the device and the connect. I think we need to recompile the kernel to not to be attracted by the garbage in the logs. And replace the driver and look again for change. I think we have improperly read this value. Custom mix mask stereo switch. We need to check. All right. We're ready to connect the device. So let's do this. Now let's look into the initialization sequence. Okay, stereo switch XFFF. Oh, yes, the stereo switch is enabled. Custom mix mask is OXAA1. Okay, that's properly conforming to our settings. We just need to check that. Yes, AA1, right. Please recall that we have little Indian storage. And then what we do? Software port number is 19. Mask is X3. And updated software port number is 19. That's pretty correct. But then we find out that this is the mix routing. Is that correct? AA1. Oh, the bit 1 is set and we need to consider checking only this bit. What's the best way to do this? I think how to do it in the better way. The main problem is that we are checking 2 bits here instead of 1. So we need to compute the validation mask in a bit another manner. So if we have the stereo mode, we need to check the even bit, the only even bit. Otherwise, we need to check the corresponding bit. So we need to generate the proper masks. So we need to so I think I need to rename the custom mix mask just to custom mix here. And rename it here and here. And introduce a new variable custom mix. Assign to 0. And custom mix mask will be other value which we will compute later. Okay, and the custom mix mask is assigned here, we just will reduce the name of the variable, and that's fine. Okay, what we will do here? We will update the mask value. We will compute the custom mix mask according to the stereo switch. So initially we will assign the custom mix mask as just zeros shifted to left by the index. By the other side, if there is a stereo switch enabled, then we need to switch custom mix mask. We need to shift 2 by the stereo index. And only when the custom mix mask is set to 0 probably, or 1. I have forgotten. I need to check the note. 1 is mixture is disabled, and 0 is mixture is enabled. And let's look back to the settings of the device. There was one. Oh, the lower bit was becomes reset, so we don't need to switch 2, we just need to switch 1 by stereo index. And here we just check the custom bit mask and the custom mix with the custom mix mask, and it should be 0. Or we can swap the code. So custom mix and custom mix mask. If it is not 0, then the physical input is connected. Otherwise, the routing is applied to the mixture output. So that's it. Okay, and seems that this is more proper behavior. The mixture output is routed to the physical output. Okay. Now we need to check. And the second problem was that we have improperly converted the value. So let's look. Software port number is improperly decoded. Even we have right index computed. This is probably 23. We need to check. We go to the port definition and look. None is 1, then 8 and 2, 10, this is 11, and 8, this is 19. So the next will be 20. And we have converted to 0. That's strange. Get software to driver port mapping. Okay. Oh, sorry. Scar to driver port number to mux enum. Scar to port at none. Direction port type port number. Software port number -1. The software port number is which is 2. Oh, the number is 3. That's pretty correct. The 3 -1 is 2. And the 2 should be encoded and as 23. And that didn't happen. And that didn't happen. Why? I believe because the software port number is less than non-count. Oh, I did a mistake. I was required to swap these with this. And probably now all will work in the right manner. So I need to just recompile the driver and check again. Oh, there's a warning. Custom mix mask is used uninitialized. Oh, that's why, because I have renamed the variable. So here should be custom mix. Where's the custom mix mask? More custom mix. There's right custom mix mask and custom mix, checking with the custom mix mask. And if all is okay, then all is okay. All right. I need to add the bookmark. To not to lose this code snippet. All right. Let's do this. Make J8, and we're waiting for the driver being compiled. Now it's ready, and we will change the driver. Oh, I believe. Oh, that's good. Register new interface driver sound USB audio. All right, and now how did it this? I just need to reinitialize. Yes, now that's pretty good. And now we're ready to launch the connection. Let's look. Okay, what do we see here? We see that the PCM output, probably PCM output. was applied. And yes, PCM output was applied to the analog output, the PCM, or PCM input 1. PCM input 2 was applied to analog output 2. Then the mixture 3 was applied to analog output 3. Mixture 4 has been applied to analog output 4. Mixture 5 has been applied to analog output 5. And mixture 1, 4, 5, 6, 7, 8, 9, 10. Yes. And mixture 1 has been applied to PCM 11 or loopback, and mixture 2 has been applied to the PCM 12 or loopback 2. So let's dig into the ALSA mixture and look what's happening. Where's the routing? I believe the routing is somewhere nearby. I need to switch to all controls, and there's the routing. So we need to look at the PCM 11, and PCM 11 is assigned to mix A, and that's right. We see PCM 12, and this is assigned to mix B, and that's right too. And now let's check for the assignment of outputs, analog outputs. D, A, F. A, B, C, D, E, F, G, H, I, J. The last mix should be J. H, I, J. Yes, right. And now this is the mixture input routing. That's not interesting for us now. And now let's analog output assigned to PCM1. That's right. Analog output 2 assigned to PCM2. That's right. Analog output 3 is assigned to mix G. Oh, that's right. Since the analog output 3 is not the actual analog output 3. It's the last in the list. So this is A, B, C, D, E, F, G, H. So this is the last pair, G, H, and that's true and that's right. G, H, then mix C and mix D. That's right. Mix C, D, and mix E and mix F. Mix E and mix F. And GH and IJ should be assigned to the SPDIF. Mix I and mix J. That's good. So at this moment we have properly read the routing of the mixture and applied this routing to the our configuration, our routing. We have properly read the software routing and applied this to the hardware routing. So by the our other way, we need now to work properly with the changing of the routing. So we can change the routing in two ways. The first way, we can just select the value applied and apply this here. And the second way, we can change the routing by switching the stereo button. Oh, that's pretty hard. And probably I think we will start with the applying the root. So let's look. We have the function that changes the root. I believe this is the function, the Scarlett 2 mux commit root. And we will start doing this thing here. So we need, additionally to this code written previously, we need to check that the stereo mode is enabled. And if the stereo mode is enabled, then we need to properly encode the number of the port of the output here. and write the proper mask, and write the proper mask to the bit mask. So for this case, we need to read this value from the software config first, the mask value from the software config. So the U32, how did I call this? Custom mix, and this value should be assigned here. Read the custom mix settings. I also will I will correct the comments to be C style comments, multi-line C style comments. And here I will do the following thing. First of all, I need to read the custom mix settings, and I will just do this custom mix. Assign the value private software config, and reference the field as custom mix. So now we have the custom mix mask. That's good. And we need to convert it to CPU configuration, memory layout, CPU LE32 to CPU. Oh, that's good. Okay, done. We're ready. And at the end, we need to update the mask too, and commit it. So we will update the new custom mix here. So updating the output number. Okay. And here we need to compute the new custom mix mask and update it if it is necessary. So compute the new custom mix mask and commit it if it is necessary. Okay, then new custom mix. If new custom mix is not equal to the custom mix, then we'll do. I will rewrite, commit the custom mix mask if it is necessary. So here we will just check that the custom mix mask has been updated, and just commit the new value. Here we'll remember the previous value. That's okay. And here we'll commit this, and here we need to check the error. If error is less than 0, then we just return this value. And we'll do the same pattern here, but write the value private software config, custom mix, and here we do the reverse conversion, the CPU to LE32, and pass the new custom mix value, and then just ship the value to the device. So scar2 commit software config mixture and the address of this field that we need to commit. And the value of this field is 32. The size of this field is 32. That's pretty enough. That's pretty good. The only thing left is that we need to properly convert the output number. So here we need to analyze the driver port type. If driver port type is a mixture, then we do one stuff, and if it is not the mixture, then we do the second stuff. That if driver type is Scarlett 2 port mix, then we do the stuff, else we do the usual stuff. Here we write the comment that the physical input is routed to the physical output. All right. And here, moreover, we need to update the custom mix mask. So we also need the stereo switch button. Stereo switch button state. And here we need to remember this value. And stereo switches. And here we just read this value, stereo switch LE to CPU software config stereo switch. That's pretty good. And now we're ready to do the primary stuff. Here we just reset the custom mix mask by setting. We need to also, since we know the input number. Oh, so since we know the input number, right? Right. We know the input number. And here we just need to decode the right value for the input number and set proper mask. So let's do this. So we need to int stereo index. So we'll call this in this manner, and we'll compute the stereo index here. Stereo index is it's just the that's pretty not trivial, I believe. So I need to look how this function is called and how the stereo index is computed there. Stereo mode. So we're counting the mask here, and there is some magic. I think the stereo. Oh, okay. We can compute the stereo index here. Since we know the software output number, we can just compute the stereo index as the software output number -1, -1, right? And without the least significant bit. So here is the stereo index. And we can update the custom mix mask by just setting ones to the corresponding bits of the new custom mix. So new custom mix is set to 3 shifted by stereo index. Okay, that's right. Oh, software output number. We can do this. Oh, we have. Oh, here. Oh, the input number is obtained here. This is the right output number. I think that, yes. So I think that we should compute the software output port number first. Yes, and after that we need to compute the input number. Then the input. Yes, and that's good, and that's better. So the obtain the input number. Yes, and here we just do the following thing. If that's the mix, then we do the stuff, else we do the following stuff. And here we can compute the stereo index after we have obtained the software output number. Yes, that's good. And after that, we know the software input number, and all is pretty good. And we can set the we move this comment here, and here we'll move the comment about the output number. Yes, that's good. And here disable custom mix in the custom mix mask. Disable the custom mix in the custom mix mask. Okay, that's good. Right. And here we just do the same thing. We just know that this is the mix. We convert the mix to the number of the mix by a simple operation. We know the port number, and we just add 1 to this port number, and this is pretty simple. So software input number is 1 plus the driver port number. Oh, so we need to convert the, yes, we convert to, we need to convert the input number mux now to driver port number, right? And now we just update that software port input number is 1 plus driver port number, or driver port number plus 1. And after that, we can enable the custom mix in the custom mix mask. And here, here we need to consider if we are in the stereo mode or not. We need to check that. We need to set the mask. We need to compute the mask, custom mix mask. and apply this mask. So here we apply new custom mix and apply the custom mix mask. And here we refuse this mask. So we do the reverse thing. We just do the not custom mix. We apply not custom mix mask. Bit inversed. And the only thing is to properly compute the custom mix mask. And here we need to do this. So we know the stereo index. We need to check that the stereo is enabled. So if so the custom mix mask, we will assign if the, and where's the index? Oh, stereo software output number. So we need to add the index, and we'll do the index is equal to software port number -1. That's good. And stereo index is the index and not 1. Okay, now we're ready to just compute the custom mix mask depending on what we have in the um, stereo switch. So stereo switch and 3 shifted by stereo index. And if it's true, then we compute the custom mix mask as 3 shifted by stereo index. Else we consider this as being this channel being mono, and we do the 1 shifted by index. So, and after that we are ready to apply the changes. So I think we need to log the changes to see what's happening. So I'll copy this debug output, and here we will write the proper values to the log. So I think this is pretty good to write the message here and write the wall settings. So stereo switch OX stereo switch. Then custom mix. Then we don't care about the new custom mix. We have the index. So we write down the index. Software output number, of course. And stereo index. There are many variables. So stereo index and the custom mix mask. And the custom mix mask. Okay, that's pretty enough. And after that, we will write that the custom mix has changed. From the previous value to the new value, and log both. So there is custom mix and new custom mix. Okay, that seems And here we also have the information that software config has been updated. And I think, yes, that's pretty enough. So we have updated the routing, we have updated the custom mix settings, and probably this will solve all our problems. Let's check it. Oh, what? Oh, okay. That seems to be normal. Okay. Let's do the compilation and check. We need to disconnect the device, of course. So let's do. Oh, that's the problem. Steer index undeclared. 2227 line. Steer index. Oh, the steer index. Yes. And Scarlett 2 port type mix, not port mix. Scarlett 2 port type mix. All right. What's next? And unused variable. Okay. Let's do it again. Now it compiles. That's good. And we're running into the finalizing the kernel module. And now we're ready to update it. Just a few moments to wait. Yes. We are updating the driver, and now we're ready to look for the device connection and how it will interact with the mixture. All right. We have our driver initialized. We have proper configuration. Now we will issue some changes to the routing and check how it will affect. So let's see. Now we have the SPDIF configured as the stereo. Right. And we will just downgrade the mix number. So mix to G and H. And let's look what happened. So what do we see here? The mix commit root, yes, stereo switch FFF, custom mix A1, software power output number 8, SPDIF. Yes, that's right. Index is 7. Oh, probably I'm wrong. I was wrong. Oh, I wasn't required to subtract one from software output number. That's my mistake. So I don't need the index at all. So I just need stereo output. Okay, that's wrong. So I need to redo all the stuff. So software output number here. I don't have the stereo index, I have the stereo output, so I use the stereo output instead here. And I don't use the index, I just use stereo output. I don't have the index, I use the stereo output. And do I have the index somewhere? Oh, one. Shifted by software output number. Yes, that's the output number, and it starts from 0. Yes. And nothing more. Nothing more. And I believe that I need to recompile the driver. And while it is compiling, I need to reconnect to the Windows machine and update the routing. returning back to, I believe there will be something strange. Yes, custom mix. And where's this PDF? Custom mix, custom mix. All right, there's custom mix. Okay, let's look back. What's there? The driver has already compiled, demask, and connect the driver. Let's look at the routing. Mm, 8, 9, 1, 2. Probably it hasn't changed the value. That's good. Let's go back. It's G and H. Okay, let's look again what will happen when we will update I and J. So let's look. So the custom mix is 8 to 1. Probably key. Software output number 8. Stereo output 8. That's good. Custom mix mask 3. Okay. Scarlett to commit software config. Offset. Oh, that's okay. And nothing more. So we have custom mix enabled. Okay, good. Let's check how we'll switch from custom mix to non-custom mix. I believe the problem that saved us was that we didn't switch from custom mix to something else. So now we'll switch to PCM outputs, and look what's happening. Okay, what do we see here? We see 8 to 1 mask still, output mux 19, and what do we see? Scarlett 2 use B set offset key. We see that custom mix. Oh, okay. We see that here we have configured that. What do we do? What do we do? Commit software config. Oh, we have committed the routing, and the value is set to 19. Okay. And here we have updated the custom mix to B21. And that means that the custom mix is disabled for this pair of outputs. And they are routed to the PCM1 and PCM2 as now the only thing that we need to count the number of the input. So let's go to the device description and look for the port assignment. We have inputs. One input. We have one non-input. We have 10 inputs for NL condensed PDF. So this is 11 and 8. This is 19. And this seems to be not correct. Software config output mux is set to 19. No, has I something counted wrong? Oh, I believe this is related to outputs or inputs. I need to check again. Still, port port in and port out constants. Constants. Port in is 0 and port out is 1. Mm, so, mm, still it shows the proper PCM 1. So where was I wrong somewhere in my computations? 19 and 20, set to 19 and 20. And then I'm gonna SPDIF are 10, 18, mix. That's pretty strange. Oh, ow! I believe I know the PCM is before the mix in the enum, and that's right. Okay, I think I need to correct the driver description since the PCM is after the mix. Then I don't understand at all. How does it compute the value? Or is it? I need to check the log. Software config output. Oh, that's the software config. That's right. Now, that's not the mux config. So, yes, I just need to log this. The mux output num is the value. So now it's clean where I was wrong. That's good. Okay, that seems that it is correctly applied now, and I believe we will see in the assignment of the SPDIF that the routing was properly set. I think we can disconnect the device and check. And we need to look at the SPDIF. And it is assigned to the playback 1 to 2. And that's pretty right. So, now what can I say at this moment? I think we can stop at this moment. And my usual homework will be to write the proper code that handles the stereo switch. And properly enables the routing for the stereo switch. Or maybe it works, or maybe it already works, but I need to check this. The only thing left is to commit the changes of the driver to the upstream or to the my Git version of to my Git repository. I will just connect to the machine, copy the driver, we'll review some code, and then we will check. So there's homework, and we will copy the new version of driver. here and replace mixture Scarlett gain 2C and mixture Scarlett gain 2C. Yes, that's pretty good. And let's look at the log again. Git diff. What has changed? So we see that we have changed the software configuration area initialization. We have renamed the mixer bind to custom mix. That is more proper naming. We have Scarlett. We have updated the Scarlett to mux commit root function to properly handle the value of the stereo settings and the custom mixer routing. And we have updated the mux source enum control put function. And we have updated the Scarlett to add mux enums control function that will also handle uh, the state of the custom mix and introduce the proper handling of this state. So that's pretty enough today, and we are ready to commit the changes. So we do the git add dot git status and just git commit with message edit support of custom mix routing for the device. And git push. Nice. The new version of driver has been pushed to the Git repository. So I think we can end up with this today. Thank you for watching. I hope my videos are helpful to you to understand the the information about how the Scarlett devices are organized, about how they do work under the hood. I think this is good reason to set thumbs up, to subscribe the channel and to watch new videos. Don't forget to click the link to get more notifications about the changes of the channel and to make it growing. Also, it will be good if you could support me. Every donation helps me to purchase new Scarlett device for testing of the driver. And I think if you have questions, you can ship them to me directly or ask on the next stream. So I think that's all today. I know my homework, and probably the next time we will learn something new about the Scarlett device and the Focusrite control center software. So see you soon. Good night. Bye bye.